Hello, in this video I will present the solution to Chapter 8 review question number 22. What happens to the y-coordinate of a point on a line with slope equal to 15/8 if the x-coordinate is increased by 12 or if the x-coordinate is decreased by 5? One of the concepts that you need to keep in mind as you work through this problem is that slope is a ratio of rise to run. Rise and run rhymes with y's over run. Sometimes we use delta y and delta x to represent the change in y over the change of x. And I also want to remind you that this side here, which is the change in your y, is the opposite side of this angle. And this side is the adjacent side. And opposite over adjacent is nothing other than the tangent ratio. So the things that are going to be connected in this video are slope, the tangent ratio, and also similar triangles. In the case of this particular problem, what you have is a rise over run ratio given to you of rise 15 for every run of 8. And when you're asked, what happens if the x-coordinate is increased by 12? What you would get is a triangle where the x-coordinate is increased by 12, and this is what will happen to your y-coordinate. And as you can see, this triangle is a similar triangle to the one with the 8 and the 15, and all triangles that you create where the sides are parallel to the axes will be similar to this 15 and 8 triangle. And to solve this, it's quite easy. You just do a ratio, and I would stick with this rise over run. So let's use green for this one. You have a y that you want to find. You have a run of 12. And you know on this line, the ratio of rise to run, the slope is 15 to 8. Solving that, you get 15 times 12 over 8. And you cancel the 4's. And what you find is that a run of 12 is associated with a rise of 45 over 2. That would be this length for that run of 12. In part B, what you're doing is instead of running by 12, you're going to run back by 5. And what will happen is your y-coordinate, instead of going up, will go down on this line. And notice also that this triangle is similar to this 15 over 8 triangle because this angle, they're alternate interior angles which are congruent when lines are parallel. And the same goes for this angle, and these are right angles. So these triangles are similar by AA. So in the case of part B, this is part A over here. In part B, you want to know what happens if your run goes down by 5. Well, you will maintain the 15 to 8 rise to run ratio, and your y-coordinate will go down by 75 over 8. So if you go back 5, you'll go down 75 over 8. These triangles are similar triangles, and the corresponding sides of similar triangles are proportional. So in Chapter 8, there's a connection also to slope and the lines that you'll be working with this next year in Algebra 2 Honors, where every time you're given a slope, I'm hoping that you'll also be able to visualize that all you're doing is solving ratios that involve similar triangles. Let's see if I can get these to line up. So there's your 8. This is what would happen if you ran 12. Here's your 8. What would happen if you go back 5? All these triangles are just similar triangles to the one you started with, set up when you were given a slope of 15 over 8. Hope this clarifies this question, and that's it for this video.